Welcome. Good it's afternoon, good morning, whatever applies to you. My name is Sabine Brunswicker. I am the director of RCODI and also the founder of IronHacks. And my team and myself are very proud to introduce you to IronHacks and COVID-19, the new series of data science challenges that we are launching now. And it will be the first now in summer, but there are more to come. I'm going to share my screen a little bit, and hopefully that's going to work. Lead you through a presentation, at the same time also showing you the platform. I'm assuming you are not a registered user yet, because if you are, some of the things I'm going to talk about are new to you, not new to you. So that's why I want to make sure that this is important, that you are not a registered user. If you are, please let us know in the chat. I'm going to share my screen now, and hopefully that is working. And then we should be ready to go. IronHacks, hacking for innovation to solve global challenges. That's our mission, and I'm excited that you are interested in participating in an IronHacks COVID challenge. What am I going to talk about? I would like to tell a little bit more about us, who we are, background, then a bit about IronHacks and its past and its future. And the future is data science and data science challenges that focus on societal challenges like COVID-19. We at the Research Center for Open Digital Innovation, or RCODI for short, we want to empower individuals using digital technologies to solve grand challenges. And important technologies are the cloud, but there's also machine learning, AI, libraries that are built that data scientists can use to actually solve really important problems, and where data is available, or where data is available through platforms like IronHacks. IronHacks is a platform that opens technologies and data to individuals, gives them a hand to solve problems. We come from different backgrounds, so we are social scientists on the one hand, on the other hand, we're also familiar with information systems, software engineering, and also data science. So it matters both to us, and here you see a group of people that are involved in IronHacks. So it's not just me, but also a lot of other people that make IronHacks work, and I would like to use that to also thank them at this point in time. So what's IronHacks? IronHacks is motivated by the idea that innovation has changed. In the past, it was all about special people that were hired by big companies, walled off, and were not allowed or were asked not to interact with a lot of others. And if you're not part of that group, you really wouldn't have access to data and technologies to actually solve problems. Life has changed. We live in a different world now because we have platforms that give individuals access to data, to technologies, and they can make a difference. They can solve problems using data out there, or learn also using this data and advancing their skills. You might have heard of Topcoder, you might have heard of Kaggle, you might have heard of the Netflix competition, where it was not an employee of Netflix, but actually a participant of a challenge, or you can also call that crowdsourcing, who solved the problem and developed a new predictive algorithm. So IronHacks follows this idea, and so it's about giving individuals the opportunity to actually tackle problems that matter for our society, or that are really hard, where we need a lot of people to look at, because a few people cannot solve that on their own. So it's a platform that allows people around the world to use data to solve problems, simply put. The problems we're focusing on are societal problems: healthy living, affordable housing, and now COVID-19. Those problems that matter to everybody. COVID-19 is something that we cannot, as an individual, tackle on our own. We need many people to look at the problems. And some of the problems we are looking into in these challenges is predictions. So what are the predictions related to COVID impact, societal and also economic impact? IronHacks is different from a hackathon you have participated in potentially in the past, where it's very short, only a few days, and where you typically work physically. IronHacks is virtual, it's iterative, it's learning oriented. And it's also for building upon the idea that, there's also the sharing of insights among each other, or to some extent, that it's not just proprietary code. You get unique data you would typically not get access to, or data that are pre-processed in a way that you can get started right away. Because as you might know, in many cases, the data pre-processing is the hard part. It's a competition, it's an individual competition where you should try to outperform others with your submissions, but at the same time, we also want to make sure that you learn either using our features on the platform, tutorials, or by actually learning from others or prior solutions that have been developed, because we give you access to that. There are lots of partners that support us, and you see those that supported us in the past. And those partners were helping us, particularly focusing on web app development, where it was about mesh app design. So if you've looked at the ironhacks.com website, IronHacks in the past looked into web development. So the skills of the participants were geared towards HTML, CSS, and JavaScript. We often had beginners that within just a few days, or let's say 21 days, we're able to actually put up an app that's interactive, that meshes up data in a very interactive way, using a map, using charts, and actually connecting them so that people could make better decisions related to questions. Where's a safe place to live? Where should I go and buy also healthy food? So, and then the second really important element of IronHacks, besides the societal challenges, is the iterative process. So we give you the opportunity to submit throughout before the final submission phase so that you can get evaluated and then improve your solution. That gives you the opportunity to actually tune your model, or if it's a data science challenge, or your code further and make it better. In the end, we will have an award ceremony, so it's iterative. The platform itself has features you might get to know or already know in case you've looked at it. So there's an overview page where you can register to a hack. You also have an editor that's in the cloud. You have a dashboard that shows you results, and you have a forum where you get informed about new announcements from the team. The cloud-based editor in the past was geared towards web app development. So it had, as you can see here, that's a website that was built in HTML, CSS, and JavaScript. You had then also the ability to immediately see your results. You didn't have to host it. It was all taken care of, similar to CodePen. Well, we have left that all behind because we're now moving to data science, but the platform is developed in a way that it is geared towards different types of challenges. So, and I would also like to mention that it has been supported by NSF, National Science Foundation, because they ask us to examine how can such platform actually improve the productivity of participants so that they develop better solutions, more novel solutions, because the platform supports them, or because the way the interaction on the platform is structured supports them. And that is our goal also as we're moving forward, that we are learning more about how we can use digital platforms similar to a Topcoder or a Kaggle to improve the productivity of participants. I'm not going to go into the details of the architecture, but it builds upon state-of-the-art technologies. It's built in the React, and it's serverless. So here just an overview of number of participants we had in the past. So shows that we have learned how to run those challenges. Participants always had the opportunity to win cash prizes, or in some cases it actually is delivered via Amazon gift cards because it's easier, particularly given COVID-19, that's an easier way. Otherwise you have to reveal a lot of private information. But there is cash involved, but you also have other opportunities. You get a certificate with the logos of the partners. You have career opportunities because you can speak to your partners. They actually look at the winning solutions themselves and want to feature them. And you can also use that when you apply for a job or if you want to change direction. And there's also global recognition because we're actually going to feature the best solution, not just on our website, but websites in our partners. Let's just move on here to give you an idea of a concrete problem. I already talked about that, and that was solved in the past. So students were asked, find me a safe, affordable district to live near the New York Stern School of Business in New York. That's your scenario. Assume that. Then you get a list of data sets, mandatory data sets, such as weather data and also information about districts. So these are actually at some kind of geographic information. And then the task was to develop a map that allows an end user to find the most affordable and also safest district to live. You could then also add additional properties for an end user to make choices. But the three key properties that you had to look into was safety, distance, and affordability. So it was not a prediction task, it was an interactive application that supported data exploration. You can look at some of the applications developed on our website. And if you scroll down, ironhacks.com, you see, for example, one like this. I'm not going to demonstrate this now because the focus that we're having now in data science challenge is more in prediction, but it might give you some inspiration. And you can also see that participants with no training and little coding experience were able to actually deliver something like that just in a very short IronHacks. So I talked a lot about the past. I talked about the Copeland style coding editor for web app development. IronHacks has changed. It looks different now. And I'm going to actually show that to you in a little bit. We have taken the effort over the last month to adjust its environment. And now we do have a Jupyter Lab. Jupyter Lab, in case you have experience with Jupyter Notebooks, is the next generation of Jupyter Notebooks. So it's a web-based interactive development environment where you have notebooks, but you can also work with a console. You can also have just skip the next Jupyter console or even work with the terminal. It supports really a wide range of workflows, and it's also very modular. So that's why we opted for it. There's another reason why we opted for it, because it also supports multiple languages. So it's R and Python that are kind of very popular in the data science community, and it supports that. It also supports Julia, given the fact that there aren't so many libraries, we don't recommend using Julia during upcoming data science challenges, but it's worth mentioning. Another feature that we offer now is an integration with BigQuery. BigQuery is Google's flagship in data management, data warehousing. And it might actually, to some extent, substitute other big data services, Hadoop, Spark. That's just, through the grapevine, we hear people say that. We offer you the opportunity also to learn BigQuery. If you haven't used BigQuery before, if you already know it, you can just use it. You can use BigQuery without actually, going directly to BigQuery or using it there. You can actually use it in a notebook, and you can query it with SQL, or if you are our user, you can use some of the our libraries and query it without actually using an SQL command. So what are the skills now for the upcoming hacks? It's not web development. It's not JavaScript. It is skills related to descriptive data analysis and predictive modeling. Regressions is going to be the focus in this hack, and so completely sufficient. There's no need for simulations, etc. But as we're moving forward in the future and then offer more advanced data science hacks, that might be then something we could also focus on, or you could actually perform better if you know a little bit about that. So I thought I'm going to show you the actual environment, but before I do that, a statement, it's a little bit like Kaggle. So if you have worked on Kaggle, you have worked on a notebook. We're not using the Google Colab, we're using the Jupyter Lab, but it's a data science platform that's a home for data scientists that want to tackle societal challenges. That's our focus. And a slight difference is that we offer an iterative process, gives you the opportunity to learn. So it's not your final submission that actually defines your standing in the end in the contest. So let me just right now at this point go there. So I should actually log out. Hope that's working fine now. So you should see now the platform. If you haven't gone there, you can, if you're new, this is what it looks like. I talked about some showcases from prior apps. You can find those there. Here you can explore them. But keep in mind, they were focused on another skill set. So our COVID-19 challenges are featured here on this platform. You also have a video from Josh. Josh is the chief data scientist of the state of Indiana. He is part of the so-called Management Performance Hub. It's a group that takes care of all the data issues in the state. And since also our state is becoming more and more data-driven in making decisions, he has a really important role right now. And he's also actually not sure how he can handle all the tasks at this point. That's why we started talking to him, and he says, I would like to have some students to also look at some of our data and help us making better decisions. Among him, there are others, like the director of the Department of Workforce Development, is looking into the capacities and the skills, also the interest among students, but also others to examine the data they have and data we have mined. Actually going to tell you a little bit more about what really cool data we have. So once you sign in, you can sign in with Google. I kind of recommend that. Then you should see the different hacks that are there. So I'm already registered here right now. If you aren't registered, you should see your hack open for registration. I mentioned it's open for registration. The contest hasn't started yet. We have given a range of tutorials and have also given them given registered users access to tutorial data that they can use during these tutorials. So you see that here's more detailed information. We already kind of articulate the problem statement here and also highlight what you can use, and you can already test that. So here I'm actually showing you now the workspace, and here you see, here we go. Jupyter Lab is opening. So, and can then work along in the Jupyter Lab environment. I'm assuming you are not that familiar with Jupyter Lab, or maybe with a notebook, but I just kind of emphasize, that's new with the lab, that you can also work with the console. We have multiple language support. You have a terminal as well. So during the upcoming contest, you would actually work with a notebook. And actually, I just opened it here, and then use data we provide you. And if you haven't worked with a notebook, and I'm just going to show you here one that is using data from incidences. And you see that the person here who created that had also created an interactive chart. That's one way then to perform descriptive data analysis. Also just on that here. Have another one. These are add-ons, as I will say in a little bit, that are add-on features to communicate the results. Our task will be focused clearly on prediction. And so it's really about how good is your model in predicting values for certain entries in the table where there are values missing. Let me just go back and also show you another thing. So you can also use the terminal. It tells you where you are. Don't worry about this. It's because we're using a container solution. You will always have that /1. And let's see, so you can see here my files. And you can also use a console and interactively explore. I'm not going to continue here. I'm hoping that you actually go there yourself and just play around with it. So 1 second. This is so back to the website here. Pointed out the workspace that brings you there. We also do have tutorials available. In these tutorials, we provide insight into key aspects that you would need to actually get started. We are not actually training you on actual regression models because we want to see your variability and insights so we're not giving you like best solution because it's up to you what you actually want to build, what model you want to build, but we definitely give hints. But before you actually get started, you want to make sure you actually know what a Jupyter notebook is. That's why we've given you some introduction to that. In addition to that, we also here give a tutorial on how to query the data from BigQuery in a notebook. That's quite important to know because the way it works is that you will get a key and then you use libraries. In R, it would be Big R Query, DBI, and Dribble from the Tidyverse package. And in Python will be Google Cloud package. And you query then the data directly in your notebook. I could do a live demo of that now, but for that we actually have 15 evening sessions, and we actually give people also access to the notebooks to view. So I could even now at this point, show you that. So here's a notebook viewer that actually shows you the notebook. And we also do have available them for download if you are actually participating in some of the live sessions, and you can download it and just actually run it in your workspace. So that might be some important, notebooks to look at. That's our own notebook viewer, but for sure you also have access to the code. So there's one important thing I actually wanted to know, that you also do have then a profile information, and I clearly suggest that you actually also fill that in. And your key, unfortunately right now I don't have a key, but I will have one later. We run the tutorials. You have your key for download, and you need that key to actually query the database. If you want to learn more about that, I suggest you look into our tutorials, and that you can actually access as a registered user, and that you can also then execute because you have a key if you're a registered user. If you're not sure yet whether you want to participate, you can also see the tutorials, but you won't have access to the key. Okay, let me go back. Let me also go back to my presentation. Too many tabs open here. I wanted to talk a little bit more about the actual content of the challenge. As I mentioned, it will be about predictions. Why predictions? Because as you might have followed the news, it's very hard to predict given the COVID-19 situation, because it's driven by social interaction. Social behavior is sometimes quite nonlinear. Not all of it is nonlinear. So what I've shown you here is, here's some just descriptive patterns. One is deaths, and here this one is visitor counts or foot traffic. So where do people actually go, or how many people go to certain places or brands? And you see that listed here. It's a little bit small. It shows the relative foot traffic since March on this chart until July at airports, bars, etc. And you saw that huge kind of drop when we had governors around the country decide that we should stay at home, and then also stores closed. And then there was this drop, and then we had, update in the executive orders and a slow kind of uptake. Not all of them were moving in the same direction. Not all had the same kind of slope. However, we see it's kind of some point in some it looked kind of a linear pattern. So, however, this behavior actually matters a lot. Understanding foot traffic is quite important for at least two reasons. So if I look at places where people can go and spend money, those are the places that actually expose people like you to COVID risk, because you are inside the closed building. There's a lot of controversy about closed building and spread of COVID-19 inside. One thing inside a building, but one thing that's definitely clear is in a building, it's much harder to actually adhere to social distancing rules, because if you are in a grocery store and just walking through the aisle, it's very hard to do so. And not everybody actually might always have a face mask, and whether face masks are safe. I leave that discussion out here. It's an important point to know from a health point of view. The second point is also understanding where people go and spend money also tells us something about the economic development. Where are people coming back to the stores? Are they starting to make purchases? In particular, those stores where actually it's very hard to make everything online, where you can't actually buy it online. So that's why it matters. So that's why our first challenge that we are launching now is about predicting foot traffic. And for that, we actually have data from a company called SafeGraph that is become very important today in the COVID-19 discussions, because it's also supporting the White House, for example, and other key decision makers with the data so that they can make decisions based on their insight about, for example, visitor count, but also social distancing and other data. So we had the opportunity to get access to the data of SafeGraph, and we've pre-processed the data in a way that you could get started. And as you might know, data science pre-processing is often the most time-consuming part. So that's mostly taken care of. So you already have clean data. We focus in these challenges on Indiana because we're Purdue here. So our focus is on data sets from data from Indiana and helping the state of Indiana to better understand the COVID and impact using predictions. The process is again iterative. We are right now in the phase where registration has opened. We haven't started the competition yet. Giving observations on also behavior on the platform. We see how confident people are using the environment, and also in the total amount of people right now that are active. We want to make sure that before we actually launch, we know that the solution, the outcomes will actually be beneficial for our partners, so that there is something actually they can use. So we are in a so-called waiting phase right now, but this waiting phase will be over very soon. Then there is this interim submission rounds that you can actually use to get evaluated. And then we have the final submission 4 that is then used actually for scoring your defining your place in the competition. And once you release the task statement, you will actually see the actual details on the scoring. So we consider your final submission. We also consider your effort before. So it's also important to keep in mind. So if you're trying hard before and submitting good solution, that will also count. And that's basically a weighted evaluation. So we consider one of the best solutions for prior submission and then the final submission. So where did the data come from? I already talked about that. So we have SafeGraph on the one hand, and then we also have data from the Management Performance Hub. We have data from Indiana Workforce Development. I should mention that. Unemployment claims. This is more looking into the future, like future hacks, where unemployment will potentially be in focus, and to also make predictions on unemployment. So that hopefully this is exciting for you, knowing that the next hack will have an even richer data set where you could use your skills that develop now from playing with the data or trying to actually develop a good prediction can help you to do well. All this data is accessible via BigQuery. So we have created those tables for you, and then you can work directly with the libraries to query them. I might want to also tell you, why did we decide to go for BigQuery? This big data is really big, so close to a terabyte. Putting that into your laptop is going to be too much. The first challenge, we actually pre-processed it, so it's actually not smaller and handleable. But the next challenge, it might be bigger. So if you use BigQuery and if you use some of the libraries like BigRQuery or Google Cloud in Python, you have the advantage that you can actually look at the data without bringing in memory before you decide what you actually want to use from the data. So you can already run some descriptive analysis on it before you actually decide, okay, which one actually do I need to bring in memory in my notebook, where you can actually run the statistical models and so on. You can even plot without bringing it into memory, and that's also what the tutorials show you. And I hope that you actually will use some of the notebooks we created related to that. Example again, just an overview, not the detailed written out statement, but you would actually have to develop an executable code in a notebook that predicts COVID impact. And so the prediction is the core focus. And we also ask you to actually submit the notebook. So this is important that you keep that in mind. When you make your prediction, you get, I can just call it an estimation set. In machine learning, it's called a training set. And then you do have a validation set. So where you then have the actual certain entries missing. And for those, we actually want to see whether you're good in predicting that. For those we have missing entries, because the data is not available. Visualization, you basically should then also visualize your results so that end users can understand the history and the future of COVID impact. And you will submit your results in a CSV file along with your Jupyter notebook and other complementary information. How do we evaluate yours? We will rank you in 3 dimensions: accuracy of the prediction, and then the quality of the reporting, and also the effort. We have some tutorials for you. And as I mentioned, there will be more to come. And based on requests, we're going to build more. Also related to certain statistical aspects. And there's also then a list of other resources you can explore. We always link to official documentation of libraries, etc., so that you have immediate access. You don't have to do your own search. How do we, in the end, come up with the awards and the prizes? So we're going to award the top 3 solutions based on their performance in terms of the prediction. And then we also consider the visualization as a secondary component. The prediction will weigh the most, though. And then in addition to that, we also will give improvement spirit incentives. So for those that didn't make it to the top 3, if you are, for example, in the top 25, you still have the opportunity to get some cash incentives. Same also applies for those of you among the top 50. There's also some cash incentives. So we want to make sure that people that actually try to make it among the top 50 also get a small incentive. Besides those cash benefits, there are a range of additional benefits I would like to highlight. And I'm speaking here on behalf of our partners. It's for policymakers, it's for our state. It's for them important that we have others think about the impact. It's also for citizens, because if you know what kind of places, for example, or brands really expose people to risk, or if they give us better insight on the economic development, that's also important. And for sure, then also for COVID-19 research overall, that we have new insights into the nature of COVID-19 from a social, also an economic perspective. I conclude here with showing you the list of our partners, and I'm looking forward to your participation. And if there are any questions, you could raise them now in the forum, and I hope you found that into our info session useful. Thank you.